Hi, my name is John Rinaldi and I'm here in the Real-Time Automation Video Central. And today I'd like to talk about serial communications because I've been getting a lot of questions about serial. What is serial communications? Because everybody deals with Ethernet and all these other networks, but really what's happening down at the hardware level, and that's what I'm going to talk about today. When we talk about a computer, a microprocessor, if this is a microprocessor, there's a piece of the microprocessor that's called a UART. U-A-R-T. A UART is called the Universal Asynchronous Receiver Transmitter. What that guy does is take a byte, like A, for example. So if we've got the letter A and we're going to transmit it on the wire, that's going to go out as a series of bits on the wire. And what the UART does is take the bits of this byte and send it out. So how does this happen? Well, there's a specific format for this serial communication. When we talk about serial, we're talking about everything. SPI, I2C, RS-232, CAN, Ethernet, everything. When you get down to the wire, you're putting out one bit at a time. In the old days, you probably remember, if you're as old as I am, that we used to have parallel communications. We had these big honking cables between our printer and our computers. We had that big connection on the back of a computer. And why did they do that? Well, with parallel communications, you can send all the bits for a character all at one time because you had all these lines. Well, to get rid of all that space, to really shrink the size of these laptops, what they did was they decided to use just solely serial communication. So we really don't find that parallel around very much anymore. Everything uses serial communications. But then there's a particular format for this. Essentially what it is like this. The line is quiescent, and then there's going to be a start bit. The start bit tells the receiver that, hey, there's a set of bits coming. And I'm going to just draw it like this because these bits could be high or low over here that tell it, well, these are all the ones and the zeros that correspond to what that character is. And then there's a stop. Then there's a couple of, there can be one or two stop bits at the end of the message. This is called the serial frame. Every bit, and it's bit by bit by bit, goes out like this in this kind of a frame. So we've got a start bit, we've got data bits, and we've got stop bits. Now, typically, the start bit's always got to be there. The stop bit doesn't have to be there. You could have one stop bit or two stop bits. So there's a number of parameters that affect this communication, this serial stream. The first one, of course, is going to be the baud rate. Baud rate is the bits per second. So that's how long, when you send this start bit, is that bit going to be low. If we're going to send a 1 here, how long is that bit going to be a 1? How long is a 0 going to take? So the baud rate is critically important. And typically the baud rate is 9600 baud, but it could be as low as 150 baud, it could be 38.6K, it could be anything greater than that. So you got the bit rate. You got the number of data bits. Okay, the number of data bits is simply how many bits comprise this frame. And today, that could typically be 7 or 8 bits, but in other older systems, there is a bit could be as little as 5 bits. Then there's stop bits. Well, before I get to stop bits, there's also another one in here that I hadn't mentioned, parity. So what's parity? Parity is simply a bit that is a way of the receiver knowing if it got the right number of bits. So if this is a even parity, the parity bit is set to make the count of the number of ones an even count. So if the parity is odd, and you've got three, if you've got it is adjusted, it is set, or it's either high or low to make the number of ones an odd number of counts. So for example, if we got odd parity, there's 4 bits that are 1. The parity bit will be high, so you have an odd count. If you've got those 3 high bits and it's odd parity, then the parity bit will not be on, because you already have an odd count. So parity can be even, be odd, or they could have no parity. Well, there's also space parity, but I'm not going to talk about that today. So these are the essentials of moving data out bit by bit. You've got baud parity, start and stop. So there's a transmitter that's going to be sending this data, and then there's a receiver that's going to be receiving that data. So that's the framing, and this is totally independent of the electrical signals. And what we're talking about is just how the data is transferred from one place to another. Because this could be 5 volts, this could be 15 volts, depending upon, it could be 30 volts if we're talking about CAN. It's different if you're talking about Ethernet. So this is totally independent of all of the electrical stuff. This is essentially just the framing. And so what are these bits? Well, this is, if you've ever seen an ASCII table, an A is a hex 41, 41 hexadecimal, which in binary is going to be 01000001 in 8 bits. So what you would have to transmit an ASCII A, you have to send a 0, a 1, followed by 5 zeros, and then another 1. Okay? So that's how the data gets transmitted as in its character bit. If you're sending binary, so this could be either an ASCII A, or this could be a 67, which is this in decimal, if it's just sending binary data. So it's incumbent upon the other system to know a little bit about how to interpret this set of bits. That's a little bit past the framing, but in terms of, but we're always going to be sending 7 or 8 bits. So let's talk about a couple other things. That's essentially the summary of my serial communications and my UART talk here. So I'm going to go on in the next video. I'll talk more about what we're talking about when we talk about some of the electrical signals, RS-232, 485, and that kind of thing. I hope you'll join me for those videos. Thank you.
Beware the alligators!